Our project is harnessing energy in the Caribbean Sea. I'm Francisco Molinares, this is William Rosado, and this is Dominic Gale. So, for the past 20 years, we've been in this struggle where we're trying to find new alternative forms of energy. Many people are resorting to wind, to hydroelectric, to tidal energy, but we had this great idea. We have the Gulf Stream. Why don't we use that and try and find a way to use the strongest and most powerful force on this earth to harness energy? So with that, our problem statement is we're going to design and test a diffuser for a water turbine. Water turbines have existed already, so we're not trying to reinvent the wheel. What we do want to do is try to improve on an already existing design so that if one day we were to be able to place this in the ocean, it would actually benefit all of society. As you can tell by our chart, ocean currents are really the best form of energy we can actually have. Fossil fuels have their drawbacks, of course. You have ridiculous pollution. It's becoming more and more dangerous to actually extract these minerals from the ground with fracking, which causes earthquakes and pollution and all these horrible side effects. Our goal is to be able to implement these things in the water and have as little effect to the environment as possible while producing great amounts of energy.
In this case, we're going to be using our propulsion concepts in order to determine the possible torque that we're going to be producing on the wind turbine. Also, we're going to be using like a structure with the shape of the diffuser. The blades are going to have a specific design in order when we're going to be giving maintenance on the system. In this case, this is going to be the front part of the turbine. So we're going to be locating 3 different fins around the turbines in order to allow a rotation of the system when the flow change on the sea current. This accessory that we have here on the top is going to allow us, once that we remove it from the water, to remove only the blades and not to take the whole enclosure out of the system and give maintenance.
Hello? So basically the entire purpose of our project is to ultimately reduce the human impact in the world. So with that in mind, we needed to minimize our impact on marine life. And so what we propose is a mesh kind of protective shielding for the inlet of the turbine to prevent fish and debris from damaging the system. However, there are disadvantages associated with that system. It could potentially affect the fluid flow. So what we plan on doing once we have actually manufactured it is test it with and without the mesh, and in addition the mesh design can also be altered. And what we will do is, depending on, basically we want to see if because there's obviously going to be a drop in efficiency with the mesh associated, we want to see if the price is too great as opposed to the advantage it poses. And as I said earlier, ultimately we want to reduce carbon emissions, and because we are working on the principle that this project could ultimately be launched in the Gulf Stream, countries such as the Caribbean and Latin America could greatly benefit from this, and it would offset their fossil fuel dependency and just in general contribute knowledge to the growing engineering field. And this is basically this breakdown of what we did and responsibilities. Dominic Francisco, we were primarily responsible for research and presentation. William, as he showed you earlier, did a wonderful design, as you can see in poster. And at this time, we don't have an actual cost to 3D print the scale model. So we will figure that out over the summer as soon as possible. This is basically the timeline of what we would like to achieve over the next few months. The summer portion is missing a little bit, but we do plan on actually getting a jump start ready, trying to get the model prepared by the end of the summer so that we avoid any mishaps during the winter. And thank you for listening to us.
Yeah, I got, I'm kind of not understanding it, but I know this is all on exercise, so it's all good. But where's the generator on that?
Well, see, our project isn't to create the generator and the system with the platform, because that's one, really expensive to actually put together, and what we're trying to do is design the housing for the actual underwater turbine. So the idea is that, according to what research shows, if you add a diffuser to a turbine, it tends to improve the efficiency of the turbine, something like twofold. So the best limit states that you can really only pull about 60% power from any type of turbine, and when you add a diffuser to it, you can sometimes even double that. So that's our goal. But the only reason it isn't applied to wind turbines is because it's so expensive and bulky, and it looks really bad to have a giant diffuser in the middle of the air, that they don't really like to apply it. But since it's something that, one, it's going to be underwater, so it's not going to really have a visual effect on anybody, and two, the actual change in pressure from what we've seen is actually going to help deter wildlife from actually coming near our system. I think it's a great implementation for an underwater turbine, and according to what we've seen, it really hasn't been tried at all. So we're trying to see if we can actually do something.
Yeah, I understand that, but you're talking about an eyesore for the wind stuff, but you still need wires and transmission and all that coming out of the water
Yeah, but
and a base.
I just want you to know, for the purpose of our project, we're not going to be concentrating on the electrical components. We're going to basically analyze and using equations to figure out the increase in torque because the diffuser will create a pressure drop across the turbine, which will draw more fluid in, and ultimately this will create a greater torque on the shaft. So basically, we're going to theoretically calculate how much it would potentially increase the power as opposed to a system without the diffuser.
No, like I said, I understand the exercise. I just think if you're going to do something like this, you got to also look at the other aspects, even though you're not responsible for that. You got to look at the whole concept. In my opinion, I don't know. I mean, that's something where.
Because there are some equipment that can be used on the water and not use oil as a lubricant and use seawater. But we're still doing some research about the equipment that we can.
So are you talking about that as maybe just powering a platform somewhere by itself, or are you talking about powering a city somewhere?
Yeah, that's what we're researching, because ultimately it would need to be grid connected. At this point in our research, we haven't found any diffuser augmented wind turbines or water current turbines that have been successfully grid connected for long periods of time. They have been connected, but because of the harsh environment associated with the water, they usually fail. So.
So talk to me about your testing. What are you actually going to do there?
So essentially, the idea is that we're going to design it in CAD. We're going to try to optimize it using the help of one of the PhD students from the Maidrock lab here at FIU. He said that he would actually help us to try and optimize the diffuser geometry, the blade geometry, and all that stuff. And so once we have all that done, FIU actually has a water tunnel that we have access to. So we wanted to actually create our prototype, 3D print it here at FIU, I believe, and actually run it in the water tunnel, see the actual torque and all these things that we can get from it, and then make another version of the actual blades without the housing and compare it to what we designed to what the actual, like a regular turbine would do. So we think it's a very good way to approximate it, because the Gulf Stream is actually a very consistent water flow, and it flows about 2 meters per second, where we're kind of looking at it, which is about 15 miles into coastal Florida, off the Keys. So we feel like it's submerging it in water tunnel would be a pretty good way of, like replicating the conditions. Of course, it's not going to be exactly the same, but for what we're trying to do, I feel like it's a really decent approach, at least. And of course, everything is followed by CFD and optimization and all that stuff.
Okay, and just make sure in your models that you do simulate turbine, because that's going to be right in the middle of that system, and it's going to impact your flow. And also make sure, and so I see it as being test simulation. I see it's really important that you get the right kind of measurements, and that the test measurements are done well, so that you have the ability to prove to us consistently that with and without the shroud, you're impactful enough to justify it. And then I need you to do some kind of a cost-benefit analysis with that finding to show me that the cost of scaling in the diffuser justifies the expenditures. Then I think you've got something. Okay.
Is this, your simulation here looks like it's sitting on the bottom, is that correct?
Yeah,
Is that a-
the design is sitting up, let me show you. So, okay, here, these are 4 supports that are gonna go on the bottom.
Okay, and Gulfstream at your speed is probably 500 or 600 feet deep.
Yeah, so what we're trying to decide, and this, remember, so our project is the actual housing. We just wanted to kind of have like a visual aid to what it would be. Since the idea technically is to have this housing and then have a platform where a wind turbine would also be sitting, because why not take the benefit of having, the wind flowing over the ocean to also produce electricity? So that aspect, we're still kind of in between either that or a platform, but it seems a lot harder to be able to illustrate a design with just a, piece of metal, and we can't really show you the ocean. So we kind of just went with this to kind of simplify what we're trying to do and kind of make it easier to visualize what we're trying to say.
I know in some cases there's been some research done on these things that floating,
Yeah.
down below ship level.
Yeah, well, so our turbines are supposed to actually only be about 1.5 meters to 2 meters deep. Because anything deeper than that, the actual flow gets slower, a lot slower than what we wanted. So, and luckily for us, where we were looking at, the depth is about 10 to 12 meters to the sea floor, which is right off the coast of Florida. So we're really, we're just kind of debating that. Of course, we want to look into it to see how feasible it would be to actually implement this entire system, but for the scope of our project, we're just, really trying to design something that would work well, so that some other person can actually come in and use our research to create something.
Flashing lights.
Now you gotta make sure a ship doesn't run into it.
Yeah.
Or a shark get into the tire.